Question number 2. This question is from work power and energy. A box of mass 5 kg is pulled at a constant speed a distance of 15 meter up a rough plane inclined at an angle of 20 degree to the horizontal. The box moves along a line of greater slope against a frictional force of 40 Newton. The force pulling the box is parallel to the line of greatest slope. Part A of this question is find the work done against the friction. This is inclined plane motion. Let this is inclined plane. Mass of the particle, mass of the box is 5 kg. This angle is 20 degree to the horizontal. Box is a box of 5 kg is pulled at a constant speed. Constant speed means acceleration 0. 15 meter up a rough plane. This distance along the plane is 15 meter. Frictional force is 40 Newton acting in the opposite direction of the motion. 40 Newton. We have to find the work done against the friction. So the frictional force is 40 Newton. We are using this formula for work. Work is equal to F into D. F is uh, 40 and distance is 15. So we get 600 joule. This is the work done against the friction. Part B of this question is find the change in gravitational potential energy of the box. When the box is pulled upward, its height increases, so potential energy increases. At this point, potential energy is zero, but at this point, potential energy because uh, it is at a height h. Let this height is h. Now we find the change in gravitational potential energy. Potential energy at this point minus potential energy at this point. At this point, starting point, the potential energy is zero. So, potential energy, we will find the change in potential energy. Final potential energy minus initial potential energy. Initial potential energy is zero because height is zero. So potential energy change in potential energy will be change in potential energy will be mgh minus 0. So m is 5, g is 10, height we have to find. This angle is given. We can find the height by using ratio. perpendicular in this right angle triangle, perpendicular over hypotenuse is equal to sine 20 degrees. So we can find h over 15 is equal to sine 20 degree. H will be 15 sine 20 degree. We get h is equal to 5.13 meter. So putting here height 5.13. After calculation we get 257 joule, correct to three significant figure. This is the change in potential energy. Change in gravitational potential energy 257 joule. Now next part C of this question is find the work done by the pulling force. Work done by the pulling force, that this is the pulling force which pulls the box upward along this plane. Now we use here work energy relation. Work energy relation is this WD. I am writing in short form. WD means work done by driving force is equal to work against friction. WF means work against friction plus change in mechanical energy. So we have to find the work done by pulling force. We have to find WD. Work done against friction is given. We have already found 600, but we will find the change in mechanical energy. Putting the values WD, we have to find work done by pulling force. Work against friction is 600. We have already found in the part A. Plus change in mechanical energy. Change in mechanical energy means mechanical energy at the bottom and first we will find the mechanical energy at this point at the bottom and the mechanical energy at the top. So change in mechanical energy means final mechanical energy minus initial mechanical energy. It is very clear that at this point the mechanical energy will be only the uh, kinetic energy here. Speed is constant, kinetic energy at this point is same. But potential energy at the bottom is zero because height is zero. So uh, kinetic energy, final kinetic energy is mgh plus 1 over 2 mv square minus initial kinetic energy is uh, 1 over 2 mv square. Speed, since the speed is constant, so we will use v in both cases. 1 over 2 mv square minus 1 over 2 mv square because speed is constant. Speed is constant, it is given in the question. Mechanical energy at this point is potential energy is 0, kinetic energy is 1 over 2 mv square, and mechanical energy at this point will be mgh plus 1 over 2 mv square. We have subtracted final mechanical energy minus initial mechanical energy, and writing here we get this is cancel out, only mgh is there. So we calculated 600 plus mgh. M is 5, g 10, and h we have found 5.13. 1 3. After calculation, we get work done by the pulling force will be 857 joule. This is the answer.